Okay, there we are. So happy Thursday. We are not going to get to Brownie stoichiometry. Darn it. That's okay. We'll talk about it tomorrow. We're going to go over the balancing equations that you were supposed to do that we started on Tuesday. And then I have an exit ticket on net ionic reactions. Those of you that are here, I have it. Those of you at home, the page is going to have 2 sets on one because I did that so I could print them and cut them in half. But anyway, just letting you know. So those of you in the classroom, go ahead and get out your balancing equation worksheet. I want to see how you did. And be ready to ask me questions, whether you're here or at home.
Miss Scotches, I just joined, but I'm here.
Okay. And is that Ben?
Yeah.
Gotcha. Thank you, dear. All right. So Mother Nature decided to throw us back to winter today, I guess. We'll see if we get any rain out of it. Hopefully a little bit. Definitely chillier. And yeah, so this Brownie stoichiometry thing is not going to happen today. And I may have to change the date on that as well, but we'll see. Let's see that. And now I need to find my second period ticket. Hang on 1 second. There we go. All right. So hopefully you guys didn't have too much trouble with this, but I want to go through each of them and I'm going to call on people and see what you got. You definitely should have this out. Okay, because this is going to be your friend and you get to use it on the final. You get to use it on today's exit ticket as well. So you definitely want to have this. And I'm going to set a timer so that I don't blab exceptionally long. I want to make sure you have enough time to do 40. Yeah, 20 minutes is good. Okay. So we're going to get rolling on this and see if you had any questions. So I guess if you pin my screen on your Chromebook so you can see it in the right order, not reverse like a mirror. So those of you at home might want to do that. But let's get going. Tell me what the symbol for zinc is, Tyler.
ZN.
Perfect. And what is the charge on that, sir? Do you know?
2.
Yep. And it's positive 2. So I'm going to put the positive 2 down here because when you write an equation, you don't put charges in it unless it's an ionic equation, which we'll do tomorrow. Okay, so we know we've got zinc. You guys have done several little experiments with zinc. Okay, and then I gave you the formula for sulfuric acid. Okay, so this hydrogen at the front is hydrogen in an acid, which means hydrogen is acting as a cation, which means it's losing its 1 electron. So hydrogen, there's 2 of them losing an electron. Okay, the zinc will eventually give its electrons to hydrogen. I'll talk to you about that in a second. And then SO4. Who remembers the name of SO4? It's right there. Sulfate. Good. And what charge does sulfate ion have? Abby?
Sulfate?
Uh-huh. So in the purple sheet, what's that? It absolutely is. Okay, so if zinc's going to make a +2 ion and sulfate's a -2 ion, and we've checked our handy dandy reactivity and see that zinc is above hydrogen on the reactivity scale, I know that zinc is going to knock the hydrogen off of the sulfate. Okay, and we're going to end up with zinc sulfate, just like it says. and hydrogen. Okay, so turn to your neighbor, tell them what the formula for zinc sulfate is. Again, a formula is H2O, NaCl. What's the formula for zinc sulfate? It's super straightforward. It's not a trick question. Zinc sulfate is what, Nadia? That's zinc sulfide. Sulfate.
Oh, 4?
Yeah, S.
4 after the S.
CN SO4. So what does this mean? This is sulfur with 1, 2, 3, 4 oxygens. Nobody wants to write all of that, right? So we smush it together and put the subscript 4. That whole bundle has 2 extra electrons and it has protons, so it has a -2 charge. The zinc gives its electrons to the sulfate, if you will. All right. So that leaves hydrogen out in the cold. What do we know about hydrogen? It's what? Diatomic. Nicely done, Brooke. So again, on your periodic tables, if you don't have this, so I know the Navy periodic tables are kind of slick and it's hard to write on them, but you're probably going to be using this one the most. So just take a pencil and circle hydrogen and then go all the way across to nitrogen, circle that one, circle oxygen, circle fluorine, chlorine, bromine, and iodine. How come? They're all diatomic. Yeah, good job. Help yourself remember. So there's 7 diatomic elements. This is kind of cute, right? I'm into cute to remember things. It kind of looks like a 7, but you have to remember the 7th one's over here on the other side. All right? So there's 7 elements that always run around in their pure state, diatomic. They never are alone. Does that mean you have to use 2 of them in a compound? No. Again, just like our eggs, you have to buy them 12 at a time, but you can use them 1 at a time. You have to buy them 2 at a time, but you can use them 1 at a time, okay? Or 3 or whatever else. So hydrogen's diatomic, and next thing we have to do is check and make sure we got the same number of pieces on both sides of the equation. 1 zinc, 2 hydrogens, 1 sulfate. Remember, keep the polyatomics together. Okay, don't separate them out. They're a little bundle that stays stuck together. So this is balanced. Okay, the question is, what kind of reaction is it? Turn to your neighbor. See if you can figure it out. Lindsay, what do you think?
Single replacement.
Absolutely. Good job. Okay. It's one single thing replacing one other thing. 1 for 1. Something's, well, you know, they're diatomic, but the one element replaces one other element. All right. How many got that right? That's it? Ooh, that's not going to be pretty on the final. Okay. So got to get that straight. All right. Hydrogen and nitrogen make ammonia. So I just made a big deal about them being diatomic. I gave you the formula for ammonia. This is a super important chemical reaction. Figuring out how to do this without blowing themselves up was a big deal. Back in the early 1900s, an evil genius named Fritz Haber figured out a way to take nitrogen gas out of the atmosphere and react it with hydrogen gas. It requires a tremendous amount of pressure and a very high heat. And of course, in the early 1900s, had to get high heat. It was with fire. You know what happens with hydrogen and fire. One person who was working on this actually had a massive explosion and his lab assistant was killed. And so he stopped working on it, but Haber didn't care. He kept going. Why? And now it's just, that's because this can be incorporated with nitrates to make bombs. So the Germans were busy trying to blow everybody up in World War I and World War II, and Fritz Haber was working for them trying to do that. They used to go and get bat guano out of caves. They actually would send ships from Germany to Brazil to South America to go and get bat poop so they could have the nitrates and the nitrogen to make bombs. And then they got sunk by the Allies, and they ended up, Haber figured out how to do it. But crazy stuff, crazy stuff. Anywho, today, ironically, so that terrible person was trying to make bombs to blow everybody up. Today, this process saves lives because we can do agriculture because we need ammonium and nitrate for fertilizer. And so to grow food the way we grow it now, instead of putting cow poop or chicken poop out on your fields, you go and buy pre-made fertilizer. Anywho, yeah, so this is a big reaction. You will hear about it a lot, especially if you do anything more in school in chemistry. How are we going to get this balanced? Jude, what should we start with? Did you write on your paper anything?
For 2, right?
3.
3.
Yeah.
Do you want to, wait, you say put down the formulas? Or the symbols?
The formulas and symbols are there. Boom. So what's the coefficients we need? Are we balanced? We have 2 hydrogens here and 3 here. Is that balanced? How do we fix that?
Put 2 hydrogen.
2 here,
Yeah.
right? Because we want to get even. Hydrogen comes 2 at a time. 3 is not 2 at a time, but we can do 2 times 3. Okay. Sometimes this helps people visualize.
You put 3 on the other side.
Beautiful. Yep.
That should be balanced.
I believe you're correct. 6 hydrogens, 6 hydrogens, 2 nitrogens, 2 nitrogens. Again, that's understood to be 1. How many of you got that one? Okay, good. All right. If you have questions at home, please chime in. So what type of reaction is this? An element plus an element making a single compound as the product. Brooke. Combination. Absolutely. So I say single compound and people always want to say single replacement. Okay, that's not the same thing. You're combining the 2 elements to make one single product. Okay. And that is a combination. All right, so it's the next one. Got hydrogen and chlorine, right? And again, hydrogen's diatomic. Chlorine's also diatomic. And the next question is, how do I make this into a compound? Well, what charge does hydrogen normally get? +1. What charge does chlorine normally get? So hydrogen chloride is just this. That's the correct formula for hydrochloric acid, hydrogen chloride. It's a gas at room temperature, but when you put it in water, it becomes aqueous. All right, so it's not balanced either. This is super easy to fix. Anybody? Okay, I don't add subscripts, right? These are going together because chlorine has 7 valence electrons and needs a buddy to get an octet. Hydrogen has 1 electron, needs a buddy to get as good as it gets for hydrogen. That's why they're diatomic. But this is not +1, -1, all done, but I need 2 on both sides. Okay, so don't put subscripts on hydrogen chloride. Again, that's a combination. Questions? No? Okay. Let's try carbon with water to make carbon monoxide. So carbon and H2O, carbon monoxide. How many oxygens? Mono means 1. And we make some hydrogen gas again. Whoop, whoop. guess what? Once you get it written down properly, it's done. How nice is that, right? Carbon is monatomic. It can go around in little bundles too, but most of the time it's not. Put it in some water, heat it up. You're going to get carbon monoxide and hydrogen gas. And again, that is, this is a little tricky. What would we call this? Let's see. I would call that a single replacement. Okay. All right. Another combination reaction, calcium oxide. So calcium on your periodic table, it's in group 2, 2 valence electrons, loses them because it's a loser, it's a metal. So it's going to end up with a +2 charge. If you can't remember, find it on here. Okay. Oxygen, hopefully you guys know by now, is always a -2. It has 6 valence electrons, grabs 2 more from just about everything it comes in contact with and makes oxide. So a +2 and a -2 just go together 1 to 1. So calcium oxide. And then the other thing, of course, you already know is H2O. And this time it tells you you're making calcium hydroxide, a single compound. So hydroxide is a -1. So what is the formula going to be for calcium hydroxide? See what your neighbor wrote. Go. Hopefully they got the same thing. Jake, what you got? Yes. Nicely done. Okay, so you need 2 hydroxides to get to 0. And hydroxide is the hardest one to remember to put in parentheses, right? If you see SO4 and you need more than one of them, you're going to know that you got to put something. You're not going to put SO42, right? But hydroxide, because there's nothing here, people tend to forget the parentheses. So good job. All right, how many got that? Awesome. And I believe it's balanced as written. 1 and 1, yeah. 2 and 2, and 2 and 2. Beautiful. Okay. Am I going too fast, too slow, speed it up, whatever? Is it helping? Hopefully for some of you. So those are the 6. I wanted you to get through 6. Let's try number 7. All right. So did you do number 7? Silly girl. Anybody else scribble them all out? All right. Phosphorus, I told you, is P4. And of course, you know oxygen is O2. And it tells you what you need to do for the formula. Diphosphorus pentoxide. Logan, how are we going to write that?
E2.
Mm-hmm. Beautiful. Absolutely perfect. Go. Everybody bounce up. And stop there. What did you do with that, Bennett?
I did 2 on the right side and then 5 on the oxygen.
Perfect. Me too. Everybody else agree? Yes. All right. In anticipation of the next item, what I would like you to do. Any questions from home? What I would like you to do right now is kind of a tricky one. I want you guys to do number 10. And you're going to need this paper. Okay. And let's go through. So first of all, we've got aluminum sulfate, calcium hydroxide. Those are both ionic compounds. Okay. So what's the charge on aluminum all the time, never changes? Caden.
3 plus.
Yes. So I'm going to write them out first, and then we're going to talk about how we build them, okay? And then sulfate, we already did earlier, but Emily, what's sulfate?
Is it the SO?
Yep, SO4, and it always has a -2 charge. And again, the polyatomics, they're on the back of your purple paper, but it's a little harder to find. These are alphabetical on the top little box for your polys. So I think it's easier to find them there. So sulfate has 4 oxygens, sulfite has 3. So, but they both have the same charge, right? So we've got that started. And then when we do ionic compounds, remember the easiest way to get them correct is to do the crisscross. I need 2 plus 3s. And 3 minus 2s to get to 0. Obviously, we don't want to write all that stuff, okay? So we use our little chemistry shorthand. Al sub 2 parentheses SO4 sub 3. Questions on that? Yeah.
You wrote 3 as a subscript for them.
Thank you. Perfect. Thank you very much. We good with that one? Everybody writing it down? All right, take a second and try calcium hydroxide on your own. Why aren't you going on? There we go. Oops. We're going to finish this before we go. Go back to my Nadia, what would you get for calcium hydroxide?
For calcium.
Uh-huh.
And then I put H2O2. but I don't think
That's hydrogen peroxide. So hydroxide's OH minus, and again, it's on here. And so it's a -1 charge. So we're going to need 2 of them. And again, it has to be bundled up in parentheses. How many we got in parentheses sub 2? All right. So here's the deal. This positive can go with this negative. This positive can go with this negative. Innies and outies, that's a double replacement reaction. So our new compounds, and it's already listed for you, is aluminum hydroxide. Since hydroxide's a -1 and aluminum's a +3, I need 3 hydroxide. Everybody agree?
Yes.
Okay, thank you. Calcium's a +2, and so is sulfate. So that's easy. Again, the positive cation goes first, the anion goes second. No parentheses, because there's only one of the sulfate. So on this side, I have AlAlSO4SO4SO4. That's what that says. I could write out all the oxygens, but it's really a pain. I have a calcium hydroxide, hydroxide. ALOHOHOHCASO4. Pretty obvious. I hope it's not balanced. Okay, what would you like to do first, Tyler?
Put a 3 in front of the calcium hydroxide.
Okay, let's do that. So now I've got CaOH. Okay.
Then put a 2 in front of the aluminum hydroxide.
Okay. All right, we got our hydroxides balanced.
And a 3 in front of the calcium sulfate.
2 and 2. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 6 and 6. Woo! What do you think? Everybody write it down. Write down on your papers. This is understood to be 1. The proportions are 1 of these, go with 3 of these to make 2 of these and 3 of these. And we're going to be using that in our stoichiometry stuff that you watched the video on. Again, this is a double replacement. What's the matter? You keep laughing at me. Or are you laughing at Tyler?
Wait, I'm not gonna tell you.
It's okay. I'm easier to laugh at. All right. So again, it seems. Look, take this home and show your parents how smart you are. Okay. Look, mom and dad, look how smart I am. I can do this. Dead silence from the audience. Okay. I'm going to hang on to him. Don't cross off anything else. We're going to come back to them tomorrow one more time. Okay. Today, for the remainder of the period, I'm going to ask you to do the first 3 things on here. Unfortunately, because I stacked them to make half sheets to pass out, it goes 1 through 7 and then 8 through 14. Okay. It's just do the first 3 questions. You may work with a partner. You can work at the counters. Get your masks up over your faces and go. See if you can get this done. You'll need your purple sheet. Okay.
So we do 8, 9, and 10.
Yes. If you got the ones with 8, 9, and 10, that's what you do. Yeah, the first.
Oh, I got 8.
And you got a 1, 2, 3. All right.
Which that means
They're the same things. They're identical. Work with a buddy.
so the numbers don't matter.
The numbers do not matter. That is correct. Yes, you can leave them. Oh, thank you. Those of you at home, stick around because I'm going to show you the answers. Or for number 10 or number 3, whatever one you're working on. Okay, don't leave yet. Please. I'm going to stop recording though while they work.